Questions at this point in time? Otherwise, we're going to talk about requirements for message authentication codes. Any questions at this point in time? Cool. Okay. Oh, Elijah, yes, go ahead.
How is that key distributed? Or are we going to get to that?
Nope. So this is the key distribution problem. So this is the drawback with message authentication codes. You have to somehow solve the key distribution problem. Same techniques as before. So this is a problem that we've dealt with before. We're not going to deal with it again. Whatever techniques we came up with previously, we're going to use now. Yes. Good question. Other questions? Anything else? Okay. So let's look at the requirements for a message authentication code. So we had some requirements for hash functions, right? There's also requirements for message authentication codes. First one is the same. We need to have ease of computation, fast. It is fast to compute the authentication tag, fast to compute the MAC value. So that's the same as for hash functions. Compression. We didn't call it this last time, but this is the same as for hash functions as well. Arbitrary length input, fixed length output. So we didn't call it compression last time, but that's the technical terminology for it. Arbitrary length input, fixed length output. All right, so these two are similar to what we had last time. The third one is the one that's different. The third one is called computation resistance. So this is the one that's different. It is called computation resistance. Given any number of pairs, messages, MAC values, it is still hard to create a MAC value for a new message without knowing the key. Computation resistance. So no matter how many pairs of messages and authentication tags you see go by, Eve is still going to have a hard time computing an authentication tag for a message if she doesn't know the key. Okay, computation resistance. This is the big one with message authentication codes, computation resistance. This is the big one. Just as a quick reminder, because then I'm going to divide you into breakout rooms and have you answer some questions. Just as a quick reminder, here's the requirements for a hash function: ease of computation, pre-image resistance, and then strongly collision-free. Or sometimes strongly collision-free is hard, and we will settle for weakly collision-free. So these are the requirements for a hash function compared with the requirements of a message authentication code. Okay, here's what I'm gonna do. I want to divide you into breakout rooms and talk about 3 questions, and the answer to these are kind of on the next slide, so if you have your slides, then don't look. I'm gonna write these on my whiteboard here, and I'm gonna divide you up and have you answer 3 questions. All right, so 3 things here. First of all, hash functions and message authentication codes, similarities and differences. What are similarities and differences between hash functions and message authentication codes? All right, in attacking a hash function, what's Eve's goal? What is she trying to do? How can she be evil and malicious when she's attacking a hash function? And then same question in attacking a message authentication code. What is Eve's goal? Okay, so what's her goal? What's her goal in attacking a hash function? What's her goal in attacking a message authentication code? So similarities and differences, goal in attacking each of them. That's what I want you to discuss. Similarities and differences and goal in attacking each of them. let me divide you into breakout rooms. We'll do 4 of them. I'll give you, I don't know, 3-4 minutes. So do some talking. Rooms should be open. You should have an invite to those. So go ahead, join your breakout room, do some talking about those, and then we'll come back together and have you share answers. Go.
I
No,
didn't
sorry,
get an invite
fair.
yet.
Open all rooms. There we go. Now they're open. Go, for real. My bad.